Hey everyone, hope you had a great long weekend. Since there is a short week, we only are going to assign one Google form, and this Google form is going to have 11 questions that all have variables on both sides of the equal sign, and you're going to have to solve the equation. So we did something similar last week, but all the variables were on the same side. So that's what this video is going to focus on, the difference between solving equations that have variables on just one side compared to variables on both sides. So from last week's video, we solved this problem. This is from the video last week. We did 2x minus 3 plus x minus 7 equals 20. So notice where the equal sign is. The equal sign, I'm going to draw a line through it right here. And on the left-hand side of the equal sign, there's a whole bunch of stuff happening. There are two terms that have variables that are both on the left side of the equation of the equal sign. And there's also two constants on that side as well. So if they are on the same side of the equal sign, how I put them together is just with addition. So I add 2x plus 1x to get 3x. And then I add the negative 3 plus the negative 7. I add those together to get negative 10. And from here, the problem looks much easier. So I solve it by adding 10 on both sides and then dividing both sides by 3. So the last couple steps should look very, very, very similar or familiar to you. So when you have variable terms or constant terms on the same side of the equal sign, you are going to combine them with addition. So you're just going to add whatever is there. So like I added 2x and 1x, I added negative 3 and negative 7. But the stuff we're going to do this week is going to be a little different. So I'm going to write down this exact same problem, but I'm just going to move one of the terms to the other side. So I took out this x and I just moved it over to the other side. So now when I draw the line through the equal side and I look at those like terms on the left, now there's only the negative 3 and the negative 7 on the left. So those are going to combine in the same way that I had before. Negative 3 plus negative 7 is negative 10. But now when I look at those variable terms, they're the same two variable terms, but now they're in different places. So if they are on opposite sides of the equal sign, then you combine them with the inverse. So the inverse of adding x on both sides will be to subtract x on both sides of the equal sign. So whatever you do on the left, you have to do on the right. So you have 2x minus x. 2x minus x is 1x. And so then you have x minus 10 equals 20. And then you can add 10 again on both sides to get that x alone. So x will equal 30 in this case. So in this new problem, we had like terms on the same side, negative 3 and negative 7. I added them together. But then when I had like terms on opposite sides, 2x and x, I did the inverse of adding x, which is subtracting x on both sides. So if I have opposite sides, I need to combine them with the inverse. Okay? So for example, if I were to complete problem A, which will say, I don't know, 10x plus 3 equals 8x minus 15, and I look at where the equal sign is, I have variable like terms on opposite sides of the equal sign. So since they are on opposite sides, I combine them with the inverse. So if there's a positive 8x, I should subtract 8x on both sides. So that leaves me with 2x plus 3 equals negative 15. So I subtract 3 on each side. And then I divide both sides by 2. So my x value is -9. Now remember that we can check these problems. If I plug in a -9 here and I plug in a -9 there, I should end up with each side being equal to each other. Okay, so that problem was kind of straightforward, but the next one I'm going to add in a whole bunch of stuff. So I'm going to do -3x plus 5x minus 5 equals -3 times the quantity x minus 1 plus 7. So this problem is huge. How am I going to attack a huge problem like this? Well, let's go over our steps, what order we should do stuff in. So anytime I look at one of these problems, if there are parentheses, I should use the distributive property first. Okay, so I'm going to distribute first. Then if there are any like terms on the same side, oh, that's wrong. If there are any like terms on the same side, I want to combine them together with addition. I want to add them up. Then, if there are any opposite side like terms, if there are any opposite side like terms, I'm going to put them together with the inverse operation. Okay, so I should do the variable terms first, and I should do the constant terms second. And that's for when there are like terms on opposite sides. So when I look at this problem, I'm going to draw a line through my equal sign. And is there a distributive property? Yeah, there's a distributive property with this -3. So I'm going to distribute that -3 first to get -3x and then plus 1. And then I'm just going to bring down the rest of my problem here. So I've got distributive property first. That's done. And then are there any like terms on the same side? There definitely are. Because on the left over here, there's -3x plus 5x. So I'm going to put those together to be 2x. And then on the other side, I have two constants together. So the two constants together, 1 plus 7, I'm just going to add those up to be, oops, sorry, that shouldn't be a 1, that should be a 3. Sorry. There we go. Sorry. The 3 and the 7, those should add together. Those should add up to 10. Okay, so now I did my like terms on the same side, and now I have like terms on opposite sides. So the like terms on the opposite sides now, I'm going to do the variables first. So I have a 2x on the left and a 3x on the right. I'm going to combine those with the inverses. So if it's a -3x, I'm going to add 3x on the other side. So that turns into 5x minus 5 equals 10. And hopefully from here, you know exactly what to do. Inverse of add 5 on both sides. So 5x equals 15. And then divide both sides by 5. So x equals 3. All right, so I had a lot to do in that problem. I had the distributive property. Then I combined the like terms that are on the same side just by adding them up. And then the like terms that were on the opposite side by doing the inverse. All right, so that looks pretty intense. Now I'm going to look at another problem that doesn't look as intense, but it kind of is. So if I look at this problem, letter C, and I start going through my steps, I should do the distributive property first. So I'm going to distribute this 2 to get 2x minus 8. And then just bring down the rest of the problem. So I did my distributive property, and there aren't any like terms on the same side. All the like terms are on opposite sides. So when I go to put those variable terms together, I'm going to subtract 2x. Because this is a positive 2x, I'm going to subtract 2x. But what happens is they are canceling out. Those variable terms totally cancel out. They give you 0x on both sides. So on the left-hand side, you have -8, and on the right-hand side, you're left with -8. Are the two sides equal to each other, or are they not? So if you have no more variables, if your variables eliminate, and this is a true statement, then there are infinitely many solutions. Infinitely many solutions. So we could either write that, or we could do that fancy R symbol. Okay, so if there are no variables, all your variables cancel and you're left with a true statement, then there are infinitely many solutions. But let's say that problem was a little different. Let's just say, for example, that I changed one sign here. Let's say I changed that -8 at the end to +8. So I would still start with my distributive property first. 2 times x and 2 times -4. Then I would try to get my variable terms together with inverse operations. Since it's a +2x, I should subtract 2x on both sides, and oh, they cancel again. And you're left with -8 equals +8. Does -8 equal +8? Absolutely not. These two sides are not equal, and they are never going to be equal, so we say there is no solution. Okay, so there's no solution to this problem. That's different than saying like 0. X isn't 0. If you plug in 0 for x, it's not going to make both sides true. So just don't kind of let that one trick you. So sometimes there are infinitely many solutions, and sometimes there are no solutions. Usually, though, there's just one solution, like this one, x equals 3. Just one solution. All right, so those are the types of problems that will be on your check-in. Let me know if you have any questions. We have office hours Wednesday and Thursday from 11 to 12, so send me an email or we can video chat if you need to. And then Friday will be our whole class video chat from 11 to 11:30. And the link to that Google Meet is in Google Classroom already, and it should be on your calendars too. Now we're going to be doing a Kahoot during that session, and I'll try to make the questions last a little bit longer so that you have more time to complete them compared to last week. All right, so I think that's about it, and I hope you all have a great week. I'll see you on Friday. Bye, guys. Thanks for watching.